This conference will now be recorded.
Okay, starting done. Hello, everyone. Good morning, good afternoon, and good evening to everyone wherever you are. Thank you so much for attending this online session on Networking in Oracle Cloud Infrastructure Advanced Topic by Sinan Petrus Toma. On behalf of Nepal Oracle User Group, I would like to welcome everyone and thank Sinan for accepting our invitation for the webinar. And one thing I must say that I would like to sincerely apology for the last few weeks. We failed to conduct the webinar smoothly from last few weeks due to some unavoidable situation. We had some storm at the end of the speaker side, and the internet is just the broadband internet connection is disrupted. So we need to we need to search for the alternative speaker, and alternative speaker has also issue. So we failed to conduct the webinar in last few moments. And we are extremely sorry for keeping you waiting. Now this time we have realized that we are desperately in need of more volunteers in the coming days, and we will conduct separate meeting with the community members for upcoming events we have and the volunteers. And Sinan is a senior solution engineer at Oracle Cloud Services Spain. He has more than 11 years of professional experience in various IT roles. He is passionate about Oracle database and cloud technologies. And as an experienced DBA and cloud architect, he speaks from his own experience and highlights the benefit of cloud. And this becomes the ritual, right? As usual, I would like to humbly request everyone to stay mute till the end of the session. And you may raise your question via text in the chat section anytime. We will grab them and reply at the end of every topic. So we will reply the questions in the middle of the session itself. And we will have a separate Q&A session also at the end of the session. And I request everyone to fill up the feedback form. We will post the feedback form URL in the chat section very soon. And now, without further ado, I would like to hand over the control to Sinan. Sinan will start with his introduction and exciting session. Okay, let's make him present. Okay.
No, sorry, wrong screen.
Okay, no problem.
Okay, can I stop the share? No. Could you please guide me to change the screen?
Okay, yeah, what I can do is I will grab the control back and once again.
It's perfect.
Sinan. Actually, I'm not able to find you right now. Okay, I got it.
Okay.
Okay.
Okay, perfect. Because now I have to select the screen and then click on share. I'm very used to do it the other way around. Sorry for that. Okay, so choose and okay. So first of all, thank you, Delhi, for inviting me to talk at Nepal Oracle User Group. I really very appreciate it. I feel very honored. And I'm very happy to be here today to talk about Oracle Cloud networking. Yeah, good morning, good afternoon, and good evening, everyone. My name is Sinan Petrus Toma, as mentioned by Lily before. Thank you for the introduction. I'm very passionate about cloud and database technologies. I'm part of the EMEA Solution Engineering Hub, where we support our customers around EMEA and APAC actually as well, into their journey to the cloud, giving technical advice, doing hands-on labs, webinars, and talking about Oracle Cloud technologies. Please take a few seconds to go through our first server statement. Thank you. So this is our agenda for today. We will talk about local and remote peering, and then switch to the private and public peering. There is a bit of terminology here we have to consider when we talk about these topics. We will talk about what the transit routing is, and at the end, what are network security groups and the private endpoints to have private access to Oracle Autonomous Database on shared infrastructure. And for each section, we will have a short demo in the Oracle Cloud Console to show you these things in the console, how to do them, and then also what are the use cases for this topic. So why should I configure local, remote, private, and public peering, and what are the benefits of these topics? So not only the technology, but most interesting is when do I need this? Why should I do this? So local peering, as the name says, is local. So it is within one region. So we have two virtual cloud networks in the same region. In this case here, the example is Sydney. So we have the VCN 10.20 on the left side and the VCN 10.21, 16 on the right side. And now we want to connect these two virtual cloud networks. So the resources inside these networks, for example, the virtual machines, can communicate with each other. So what we will do is create a local peering gateway, which is a virtual router in Oracle Cloud and designed to connect two virtual cloud networks in the same region with each other. And when we do this, we will set up the security list rules and the route table rules to be able to connect from one compute instance, for example, to the other one privately within this region from one VCN to the other. So you will see at the left side is the 1021, and then on the right side, the 1020, so the opposite. Actually, as I want to forward the traffic from left to right and from right to left. Okay. And for sure, also configure the target in the routing table. So every traffic coming from the left side to be forwarded to the right side and vice versa. So just let me take a pen here. The issue with PowerPoint with these two screens is when I have like pen. Okay, with the pointer it is fine, but when I have a pen and I want to highlight it here, it is going somewhere else. Very strange. Let me try it with another color. is the same. It is not highlighting the what I want to highlight. Okay, so let me just take a laser pointer. Okay, so this is the 1021. Here the destination for the route table. So every traffic coming from 1020, it is being forwarded to 1021. Okay, so let's do the demo and keep the screen here so you can see what we are talking about. Okay. So now this is the Cloud Console, might be familiar to you. On the top right side, we have the regions. So in this case, I took the region Tokyo, and on the other tab, I took the region Sydney. Later on, when we talk about remote peering. Okay, so let's create here a VCN, and let's call it VCN 10.40.0.0/16. Let's copy this, and the CIDR block is this, and just to create the VCN. Okay, then I'll just go back, and I'll create one more. This time, let's call it 10.41/16 VCN underscore, and this is my CIDR block. Okay, so now I created two VCNs, and now when I go inside this VCN, there's on the left side the options that I have. I'll go to local peering, click on create local peering gateway, just call it local peering 40 if you want. Create local peering gateway. Okay, just got created. Go back to the second VCN, create a local peering gateway here as well. Let's call it LPG41. Local peering. So now we have these two local peerings created, and from one of them, it doesn't matter which one. On the right side, there's this what's called the hamburger menu, or it's like there's this dotted menu. Even more, the hamburger menu is more related to this. Like on the top left side, if you click on it, there's a point establish peering connection. Very easy, just click on it, choose the second network you want to connect to, which is in this case the 1040. Then you will get the options of the local peering gateway. This is the one we just created, the LPG40, and click on establish peer connection. That's it. Now the peering is set as it's peered and connected to a peer. The peering VCN is the 1040. And if we go back to the other one, to 1040, you will see here as well, it is peered, and the peered VCN is the 1041. So now I can go there, create the route tables, the security lists, and the subnets. And so just to save us times, as these things might be familiar to you, I just created two VCNs already, 1020 and 1021, and already set up the subnets and the security lists, as you have seen in the presentation. This is this one, ingress to allow ingress from 1021 and egress to 1021. So, and this is exactly this rule here. What we need, allow ingress from 1021, and the egress as well, allow from to 1021. And I also created compute instances inside these networks. So two compute instances, that one is called 1020 and the other one 1021. And as you would see, They only have private IPs and there is no public IP. So this is completely a private subnet as well, and without any public IPs for this compute instances. And I just got to them via a jump server. And now I am in the 1020. And if you check here, let's say SSH to 1021.2.2. Sorry, there's a dot too much here, okay, which is the other instance. And I'm just connected to it to Sydney 1021 privately, as these two VCNs are connected with each other via the local peering gateway. And now I can do it also the other way around, 1022.2, and then I'm back to the first compute instance on the first VCN. I can exit one more time and clear the screen. Okay. So now, why would I use local peering? One use case is if I am the architect of a big enterprise, have different departments, we work at different projects, or we have even different environments, like it is usual to have different environments for production and test and development. So I want to separate these resources, separation for DATI, or separation for security reasons, separation for cost, or whatever reasons you want to separate, for management reasons, all the things you know why to separate resources is a good thing for management, for security, separation of DATIs, and then you have the use case you want to communicate between these resources, between these projects, like copying data from a production environment to test and development requirements when you clone a database, for example, for test and development purposes, and so far and so on. And another use case would be if we have a service provider and they won't have to access to the resources of their customers to manage them. And then they would also connect their network to their customers' network, as local peering is also possible to connect VCNs from other tenancies. So it is a cross-tenancy peering possible if we are talking about local peering within the same region. So if me have a company and Delhi have a second company, we have separate cloud accounts, separate tenancies, and each one of us has a local or a VCN, a virtual cloud network. Then we can connect these networks with each other and communicate privately via the local peering gateway. One thing to mention is these VCNs that getting peered, they must not have any overlapping CIDR blocks. But the VCNs on the right side, so the different VCNs from the different customers that are connected with this one on the left side, these might have overlapping CIDR blocks. Okay, so remote peering, as we could imagine from the name, it is across regions. So here, a very, very similar scenario. We have the two VCNs, 1010 and this time 1020, but these are in different regions. So we have Tokyo on the left side and Sydney on the right side. We have our subnets, our resources within these VCNs, and now we create what's called a dynamic routing gateway, which is the virtual gateway, the virtual router at the VCN level that is supposed to be used to peer to VCNs remotely. And for these DRGs, we create remote peering connections. And through these remote peering connections, we create establish the connection between the region. Similar to local peering, we also need to set up the security rules and route tables, and then to allow the traffic to flow from one VCN to the other VCN, not via the internet, but via the Oracle backbone. So it is a private connection getting from region 1 to region 2 without traversing the internet. Okay, and the local peering connection here is like a virtual circuit. That remote peering connection is a component of a DRG, of the dynamic routing gateway. So very similar scenario to local peering. Difference is the VCNs now are at different regions, and we have the dynamic routing gateway and the remote peering connection object connected to it instead of the local peering gateway. And one thing to mention is also these dynamic routing gateways. They are dedicated objects. When we create them in a minute, we have them to attach them to the VCN, and each VCN can have only one DRG attached to it, and vice versa. So the relationship between VCN and DRG is a one-to-one relationship. And also as well, the VCNs must not have overlapping cyber blocks. And the two VCNs must belong to the same tenancy. So it is across regions, but in the same tenancy. Okay, so let's go to this demo now. Okay. So let's go to now to Tokyo and create VCN here. Let's call it Tokyo. Let's say 10.70, for example, just to take something that doesn't matter actually, /16, and the CIDR block would be 1070.0.0.16. Create the VCN, and in Sydney, actually we could take any one of the 40 or 41 we just created, but let's create just a new one. It's very easy. VCN, and just like to keep the numbers different for the demos, for the use cases. Okay, let's call it 1080.0.0.16. Okay, then create the VCN. Okay, and now inside each VCN, there is this point dynamic routing gateway, but first I have to create this dynamic routing gateway. So I'll go back to virtual cloud networks and dynamic routing gateway and create dynamic routing gateway. So let's call it DRG70 to be aligned with the numbers. It's just getting created in a few seconds. Let me go to Australia one more time. Virtual cloud networks, dynamic routing gateways, create dynamic routing gateway and call it DRG80. Create dynamic routing gateway. Okay, being created. If we go back here, okay, still just wait a few seconds. Okay, it's available. Now here we can go to virtual cloud networks and say, okay, attach it to virtual cloud network. So this is what we talked about, like the DRG is a standalone object, and we have to attach it to a VCN after created. So let's attach it to the newly created VCN. Attach. Okay, loading is attached, and now you see the attach button is outgrayed, so I cannot click it anymore, because as we said, this is a one-to-one relationship. As soon as this DRG has one dynamic routing gateway, so there's no possibility to attach another one to it. Okay, then let's create here the remote peering connection as well. Create a remote peering connection. Let's call it RPC 70. It's created, and the peering is stated it is new, not peered. Okay, so let me copy the remote peering connection or CID, because we will need it in a second. Okay, so from the right menu, click on copy remote peering connection. Okay, now go to Sydney, virtual cloud networks, attach this to the newly created VCN 80, attach. Okay, remote peering connections, create a new one, RPC 80. You can choose any name you want. Okay, it's connected, and peering status is new as well. And now from one of the peering connections, it doesn't matter which one, just click on the menu at the right side, and then click establish connection. And when you click establish connection, we select the region. So as we are now in Australia, we will select Tokyo, the second one, and this is why I need the CID to put it here for the remote peering connection, and then to establish the connection. And now here the status is getting pending. On the other one is a new, but this would switch in pending just in a second. Okay, let's go back here, pending, and here still new. This might take a few seconds. It is quite normal. Okay, so let's look at the use cases while this connection is being established, and look at it in a second. Okay, so for this reason, to also save time, I already created 2 virtual cloud networks as well. This one is the 10.10.21 we already had a look on at Sydney, and the other one is networking virtual cloud networks. Just got pending in the last second. Okay, it's the VCN Tokyo 10.10. So just go to the demo one more time. At Tokyo, we have 10.10, and at Sydney, we have 10.20. Okay, so we have this 10.10. We have the security lists that allow egress to 10.20, and at the other hand, the 10.20. And we have the security lists allow the ingress from 10.10. And what we have here, which is also specific to remote peering gateways, is when we have a look at the virtual cloud network, here at the dynamic routing gateways. The dynamic routing gateway itself could have a route table attached to it. In this case, in Tokyo, there is no route table attached to it. And if I click on the right side here, I can associate one to it. If we have a look at Australia, the VCN dynamic routing gateway here, there's a route table attached to it. And once a route table is attached to a VCN, you cannot remove it anymore, but you can change it. And if you want to remove it, then you could just go there and just remove all the rules inside it and keep it empty. And this is at the end the same effect. Why this is needed, we will have a look at it in a second. When we are talking about transit routing, but for the moment, for the just to be clear, for the remote peering, there's no need for the route tables at the DRG level, as these two VCNs are connected with each other privately, and the traffic flows from one to other VCN through the DRGs via the definition at the route table at the VCN level. So at the VCN level, I say the route table for the VCN at Tokyo forward the traffic for 1020 to DRG1. And as you can see here, we have our subnets, and this is my private subnet. And if I click on edit, the route table for it is route table private SN. If I go now to the private table, sorry, to the route table private, and you see for the traffic dynamic routing gateway. In this case, I just put it very easy and took all the traffic, but I also could say, okay, edit, and here it is like forward the traffic to actually to 1020/16 to keep it aligned with our example here. 1020/16 forward the traffic to DRG1. Okay, and here as well I have a compute instance which is in Tokyo. Go back here and let's say this is just my jump server, just to show you I am now SSHing to the 10.10 within Tokyo, just from the jump server to the private compute instance. And from here I could go and put SSH to 10.22.2, and I'm just connected to Sydney. And before I was in Tokyo. And this is a completely private connection without the traffic traversing the internet. And the way back, SSH to 10.10. So go from the connection from Sydney back to Tokyo, and here you go. So very, very easy. Okay, back to our remote peering connection. Tokyo 70, dynamic routing gateways to the DRG itself, to the remote peering connections on the left side, and now you see the status is peered. And now we should see this at the right side in Sydney as well. So this just took a few seconds more. Remote peering connections and the status is peered. Okay, so what are the use cases for cross-region connections? One of them is, as you can imagine, for migration purposes, for application, or if you do a backup and want to copy resources from one to another region and want to keep your connection private and secret and secure. And for disaster recovery scenarios, in case of database disaster recovery scenarios, using DataGuard, using database cloud service, for example, we have the possibility to create across regions DataGuard, keeping the primary database in one region and the standby database in the second region. If you go here, there are the console. Sorry, I have one database in Frankfurt, database cloud service. Okay, we go here to the database system and go to the database, and you have on the right side this menu. Here is enable DataGuard. And now here you can enable your DataGuard and then choose the other region and then enable your disaster recovery scenario. And for this DataGuard configuration to work, you have to peer the VCNs across regions using the remote connection we just have seen. And this is a more detailed scenario, like you have your private subnets for the database, then you have your public subnet for the application. You use traffic management steering policies and the DNS load balancer, and then having the database in a private subnet, and these networks are connected via remote peering, and the DataGuard configuration is established across regions. Okay, so other kind of connections are private and public peering. Actually, the name public peering is related to, or both of them, first go a step back, both of them are related to hybrid cloud solutions. So when you connect your on-premise data center to Oracle Cloud, and then when you access the Oracle Cloud resources in your own virtual cloud network. So this is the yellow one at the right side. And when you access these resources from your on-premise network, this is called private peering. And for this, you use a DRG as well. And if you want to access resources outside of your virtual cloud network, like resources like object storage, which resides on Oracle Services Network, sometimes called as well Oracle Public Services, and this is where the name comes from. So Oracle Public Peering to connect to Oracle Public Services, but in this case, they are not really public, so this is not a public connection. This is absolutely a private, dedicated connection as well, and the name is related to the Oracle Public Services, like object storage. But the public, the connection itself is a private, dedicated connection via Fast Connect. Okay, and the use cases for them, for sure, if you doing like hybrid cloud scenarios, you want to extend your own network on-premise, and then in this case, you would just create your virtual cloud network, keep it private in the Oracle Cloud, and connect to it to your on-premise network. and handle it as an extension of your network. So this is a purely private cloud within the public cloud. So this is private to you. You are the only one who have access to it, and this is your private section inside the cloud. And the other one is to access Oracle Public Services, Oracle Object Storage for backup scenarios. For example, if you want to, for disaster recovery using hybrid cloud, like you have your database on-prem, and you want to do backup in the cloud on object storage. So just configure this, and then the traffic would be dedicated, have a high bandwidth connection for your backups, and use, in this case, public peering, but I said the connection is private and dedicated. And one of the questions that comes when we talk about hybrid cloud, about remote peering, about traffic going from one region to another is, what about the cost? As many people are familiar with the concepts of this cost from other vendors. And in case of Oracle, all the ingress and egress traffic within the same availability domain is for free. This is a differentiator, whereas other cloud provider would be charged for this. This is free in Oracle, as well as the traffic between the availability domains within the same region. You wouldn't be charged for ingress and egress, and neither for fast connect using private and public peering. So this is ingress and egress traffic is completely free as well, which is a differentiator as well for Oracle. Where it is coming to play a role when to be charged is when we are talking about egress traffic between regions and egress traffic to the internet. Anyway, the first 10 terabytes per month are free, and it is at a very low cost. If you not to keep it very salesy to say the session, I want to talk more about the technical stuff, but just go there and compare this price with other cloud vendors, and you will see this is about 17 times cheaper than other vendors. Okay, so back to technology. Transit routing. Now imagine we have two virtual cloud networks in different regions, as we had, like the 1010 in Tokyo and the 1020 in Sydney as well. But in Sydney, we also, at the very beginning, we had our local peering as well. So we peered the 1020 and the 1021 with each other. So now we were able to ping or to SSH from 10.10 to 10.20, as we have seen here. Okay, you remember from Tokyo, I don't have it here, SSH to 10.22.2. And I'm connected now to Sydney. So from this one to this one, okay? But what is if I now want to connect, just let me exit, go back to Tokyo. What is if I want to connect from Tokyo here to this one from the very left to the very right one? So these two VCNs are not connected via DRGs or via remote peering. So what I should do now is create a DRG for this VCN and attach it here. So for the VCN 1021, and then do a remote peering to Tokyo. And you can imagine, okay, but I already have a remote peering connection to Tokyo. Could I use it? Yes, you can use it. And you can just let the traffic go through this VCN in the middle and then go forward to the very right to 1021. And using this VCN in the middle of the 1020 as a transit zone. And this is where the name comes from, transit routing, as the traffic is just getting forwarded from the DRG to the LPG, and then the LPG is connected via local peering to the other one, and then it is forwarded to the resources inside this network. So just test it. Okay, it doesn't work. I know why. Because we changed the security list in Tokyo. Go back. Network, virtual cloud network. You remember our egress rules? Sorry, this is the 70. This is the one we just created. Okay, the security lists, the egress rules from 1020. No, this is fine. 10 egress to 1020 and 1021 in Tokyo. Let's go here to Australia and check here. Networking, virtual cloud networks. Okay. To 1021. 1021. The security list. Okay, allow ingress from 10.10. This looks fine as well. Okay, ingress from 10.10, egress to 1021 is fine. And here we are in 1021, and we have ingress from 10 to 10. Okay, so the next step is now to check our routing tables. So the routing table for the VCN here, and for the DRG itself, and for the LPG itself. So the DRG now, when it gets any traffic from Tokyo, which is supposed to be sent to 1021, but this DRG is actually attached to 1020. So what to do? Okay, so this rule defines for the DRG, okay, if you have any traffic for 1021, just forward it to the LPG. And when it's getting forwarded to the LPG is connected per local peering and is aware of the 21. So the traffic is forwarded to the very right side and getting here. And the way back as well. So this LPG is connected to this VCN, which is 1020. So what happens when this LPG gets any traffic, which is supposed to be for 10.10, which is our second region here. So in this case, okay, this is the route table for the LPG. Just forward the traffic to the DRG, and the DRG will take care of it. And the DRG is aware of this remote peering connection and will forward the traffic to the very left side back to Tokyo. So then let's have a look on the dynamic routing gateway route table. Dynamic routing. 1021. Let me just check one more time, please. Okay. Exactly. So you see, 1021 doesn't have any dynamic routing gateway. So this is what we talked about here. This 1021 is not connected per remote peering. Okay. So go to local peering gateways, and this remote peering gateway has route table, and the route table PG2. Okay, the route table for RPG, which is this one. Okay, add route rule, and then dynamic routing gateway, and 10.10.0.0/16. Sorry, let me have a look one more time. Okay, cloud networks. Our 10.10 to the dynamic routing gateway, Tokyo. Okay. This looks fine. Gateways. Okay, this looks fine. Okay, then go to Australia, to our 1020, and check there for the dynamic routing gateway. And now we have the route table here. Okay, and now you see, okay, at this route table, the traffic for 10.21.0.0/16, this should be forwarded to the local peering gateway LPG1. So this is exactly this rule here. Okay, and now we go to the local peering gateway. Which is paired to this one, and the route table dynamic routing gateway to 10.10.16. This looks fine as well. So why this is not working? OPC that. The range, because actually, as if I'm not missing anything, the subnets, the private subnet for 10.10. Last check. Please bear with me a few seconds more. This egress for 10.21. This is fine. And Australia 10.20. Private subnet. Security list. Yes. Okay. Let me just check if the instance is running. Surely maybe there's something here. It's running. And 21 to height. Okay. Just go there and just let's exit everything here. Maybe I'm just too deep into all of these. One last try, and if it is not working, I'll fix it afterward and come back to you with what was the issue. Okay. Just to go to the private one in Tokyo, and from here to 10.21 2.2. Okay, then I'll just after the session have a look on everything one more time, and then I'll come back to Dilly. So I think he can forward the answer to you. Where was the issue for this one? Okay, sorry for that. Okay. Okay, best very last one. LPG2. Okay, the very last one. Just to check now. I don't like it if things doesn't work. Just to check this route table as well at the very right side at 10.21. Okay. Okay, looks fine as well. Okay, good. So, and then back to the presentation. And the thing is, with local peering gateway, as we discussed, we can do many of them, up to 10 actually. And from the terminology, here we are talking about the hub VCN and the spoke VCNs in terms of the private subnet, or on the virtual cloud networks. On the right side, they are connected with local peering. And we can do this scenario as well if we are using multi-cloud or hybrid cloud as well. So to access the resources via the transit routing. Okay. So last topic would be about network security groups and private endpoints for the database. So what is the difference between security list and network security group? So security lists, as you are familiar with very probably, they are attached to a subnet. So all the resources within the subnet get the rules applied from the security list. But what happens if you have different resources within a VCN or within a subnet, but they have different security requirements? So in this case, network security groups come into play, and they are not attached to the subnet, but attached to the VNIC at the instance level. So we have now here two compute VMs, and now we can attach different security rules to them, although both of them are within the same subnet. And so we can now like separate our network design or the resources, where to put them, from the security requirements and design. We will have in a minute an example where this becomes handy. Okay, so in this case, we have an example for an autonomous database, which is accessible from everywhere. So if you provision your autonomous database, here you have now two options. When you click on create autonomous database and scroll a bit down, you have two options: allow secure access from everywhere, or only from virtual cloud network. And if you choose only from a virtual cloud network, you would have to choose a virtual cloud network, the subnet, and a network security group. Okay, and in this case, we choose access from everywhere. And so if we want to have a private access to it from our VCN, then we would use the service gateway. So this is the usual use case which was available from the very beginning. So we have this private access to our autonomous database on shared infrastructure from our VCN to the database privately, but still the database here have a public IP and is theoretically accessible from everywhere. What we can do is to restrict this access, is to attach what's called access control list to it, which is a virtual firewall at the database level, and they restrict the ingress rules only from 10.21.2.0, which is this subnet. But still, the database could be accessible from the internet. So the database has a public IP assigned to it. And many enterprises, due to security reasons, they don't even want the database to have any public IPs assigned to it, even if you can restrict the access, even if you configure it to be accessed only privately from within your VCN. And this constellation were introduced to have a private endpoint within your VCN and attach a network security group into it and allow the ingress traffic only from specific VCN or even specific network security groups, which are then attached to these virtual machines and then access the autonomous database privately. And in this case, this autonomous database on shared infrastructure doesn't have any public IP addresses. Okay, so let's go there, and let me just try to connect to 1020 to Sydney, and from here to connect to 1021 2.2. Okay, now we are in this connection here, connected to autonomous database. Just let me show you this in the console. One more time, autonomous databases. I have this one here. And this got the network security group. And the network security group is allowing traffic from 1021.2.2/32. So actually only this single IP address, so only this single virtual machine is allowed to access this one, 1021.2.2, 1021.2.2, access the internet. So, and if you have then a look at the DNS names Aura, so you will see here at as a host, this is the FTQN, and you will find it here as well. So this is the show. So this is this one. So this is the private endpoint URL for the autonomous database, and this is now used as a host name for the autonomous database. What I can do here now is just change this with the IP address, just to prove it one more time, as this is a private access to the database. If we add a private IP, we go here, just do the I, and go to TP urgent. And change the host name. This one, okay. And you see here we are using exactly this service name. Okay. And connection one more time, and here we are. And when you download this wallet from the autonomous database, so you are familiar with, maybe I think you go for DB connection and download the wallet. You will get this DNS names Aura inside it, as we have seen. And now this DNS names Aura as the host, QDN is configured, and this can be resolved to the IP from within the subnet where this private endpoint resides. Okay, but if you want to access this autonomous database remotely or from other VCNs from the same region, which are connected via local peering, then this FQDN cannot be resolved there. And then we have two options. The one is like we did here, just change the DNS names Aura and put the private IP inside it, or just edit the hosts etc hosts file. So this FQDN can be resolved to the private IP if you are connecting to the autonomous database via private or public peering. So this would look like this as a summary. Before coming to an end, we have here the Tokyo region on the left side, then the Sydney region, and at the right side we have here our 10.10 VCN, which is connected via remote peering to the 1020, and the 1020 is connected via local peering to 1021. Okay, so now we can do SSH, as we have seen, from the jump server to the private instance in Tokyo, then go via the remote peering to the DRG in 1020, and from 1020 using the local peering to the 1021 2.2, and from here just we get connected to the autonomous database. And the thing what didn't work unfortunately in the presentation was this one, so the traffic to be forwarded from here to here to get the transit routing done. Okay, what we usually was used to use to connect to an autonomous database and created to be accessed from everywhere, to use a service gateway. But now, as we have the private endpoints, we can create the autonomous database only with a private IP and connect to it from our local machine through the endpoint from within our VCN without the database having any public IP assigned to it. And now if we want to access the database from other VCNs or from other regions via local peering or remote peering, this is what I talked about, is to change the TNS names or the etc hosts for the QDN to be resolved within this VCN or within this VCN. And all this for sure provided all the security lists and the route table are in place and are configured properly, then this would work. Last example is, in this case, we have here at the very right side our network security group allowing the access to the autonomous database via the 1021 2.2. Let's give me 1 second, please. Okay, so we are here in Tokyo one more time, and now I'll do like here the wallet TNS names over one more time because I'm now in another region. Now I have to do it, okay, because the private IP, and then just change this one here. Okay, and from here now I should be able to access the database, but this is the same issue we are encountering here as the with our transit routing. But when I'm able to fix this, I would be able to connect to the autonomous database from this compute instance across the route here to the autonomous database. Why is this possible? Even the network security group here is defining the access is also only allowed from 1021 2.2, which is this one. This is because this virtual cloud network subnet has an additional security list assigned to it, which is this one at the right side, and allowing the traffic, the ingress traffic from 10.2, which is this one. And this applies as well to the private endpoint. So if you have network security groups and security lists assigned at the same time, so the security rules assigned to this VCN, to this network security group, is the union of both of them. So this one and this one. And now if you want to restrict this access, you would go there and change this security list, or remove it actually, and create a new network security group and attach this rules to the network network security group and attach them to this compute instance. So you are able to SSH to this compute instance, but you are not able to connect to autonomous database from outside this compute instance here. For example, from Tokyo or from another region. So to separate, we have this example we talked about. We have two different resources within this VCN with different security requirements, and this is why we need network security groups to be assigned instead of security lists to separate between them, because the security list rules applies to all resources within the security subnet. Okay, so be aware of this. If you assign a security list, is assigned to all the resources within the subnet. Okay, for further reading and knowing more about all these topics we talked about, dive deeper into them. And thank you for staying as long. Now we have like even more than 1 hour 15, 1 hour 20 now. Thank you very much for listening to this quite long session. Now, if you want to get even more insights, go to these websites. There are much more information to read about. And now, Delhi, back to you. If we have questions, we could answer.
Okay, thank you, Sinan. Thank you, Sinan, for this wonderful presentation. And yeah, this will help a lot. So, guys, if you have any questions, then we have 5 to 10 minutes. Sinan, there is one question. I guess in free tier, we cannot create a resource in region beyond our home region, right?
I'm sorry, Delhi, I cannot hear you very well. I don't know if it is my. Could you please?
Yeah, sure. Am I audible now?
No, unfortunately not. Could you put me the question? Is the question already in the chat? If you can forward, can you?
Yeah, sure.
Just copy and paste it in the chat, please. In a free tier, can we create resources in multiple regions? Yes, you can create them in multiple regions.
There is another question too.
But you have to activate them before there is a procedure, because when you assign, you have a home region, and then you have to assign for the new regions, and then you can create them. This is related to the 30 days in that case, and after that, if you are corresponding to the not the free tier but the always free, this would be different. But for the free tier means even the first 30 days, and then you would be able to create resources in other agencies.
So
now I hear you better.
I'm okay.
Yeah.
So basically, Siman, you mean to say that free tier is different than always free, right?
Yes, so the free tier consists of two components. The always free resources and the resources you create with the budget you get, like the $300 you have to spend or you can spend in the first 30 days. And then you can create resources wherever you want in different regions and so far and so on. And after these 30 days, all the resources you created that are not assigned as free tier, you wouldn't be able to use them. And the resources as assigned as always free, they will continue.
Okay.
Okay.
And in case of always free, we cannot create compute instance in region beyond the home region, right?
Yes.
Okay.
The free tier is assigned to your home, is to your home region. But you still can take this period of time, the first 30 days, to use this period of time to check this.
And Sinan, we have another question, but it's an easy one. Why to use public address for database in the case? So is there any case we need to use public IP for the databases?
Well, if you want to access your database from the internet, if you have your application somewhere which cannot be connected to your VCN, for example, you have a hybrid cloud or multi-cloud environment, but you for your scenario, you don't have any resources to establish a private connection using Fast Connect or using Interconnect in terms of Azure, or connect your application to the autonomous database privately, or connect to the region, and want to access the database, then this database must have in some way a public IP address to be accessible from that resource. And in this way, for higher security, you would use the access security lists or the access control lists inside the database to define the security rules and say, okay, only the IP address of my application is allowed to access the database.
Okay, I guess we are done with the questions. So we do not have any more questions left. Okay, thank you, Sinan, once again for your nice and wonderful session. And thank you so much.
Yeah, thank you very much. Thank you for inviting me.
You're welcome. Bye, Sinan. Have a wonderful
Bye-bye.
weekend.
You too. Have a nice weekend, everyone.
Thank you.
This conference will now be recorded.